Dear students of class 11, now today another topic that is from ionic equilibrium buffer solution. What is the buffer solution? The solution which resists the change in pH on the addition of small amount of acids or bases called buffer solution. That means the solution which addition of small amount of acid or base, it will not change its pH. Blood is one of the most common example of buffer solution. Now buffer are two types. One is acidic buffer that contain equimolar quantities of weak acid and salt of strong base of that weak acid. As for example, acetic acid and the salt of acetic acid and sodium hydroxide, that is sodium acetate. This equimolar solution of these two act as acidic buffer. And basic buffer that contain equimolar quantity of weak base and salt of strong acid. As for example, ammonium hydroxide weak base and salt of strong acid with ammonium hydroxide, that is ammonium chloride. The equimolar solution of ammonium hydroxide and ammonium chloride act as basic buffer. Now what is buffer action? The ability of buffer solution to resist the change of pH on addition of small amount of acids or bases is known as the buffer action. Now how the buffer action done in acidic buffer, we have to understand it. Now for this we take the example of buffer action of acidic buffer. We take the example of equimolar solution of acetic acid and sodium acetate. Now in this solution, almost all sodium acetate is dissociated into acetate and sodium Na plus ion. So the solution contains large amount of acetate ion and Na plus ion, and also large number of undissociated acetic acid. As because acetic acid is weak acid, it dissociated very less extent, so undissociated acetic acid will be there in large amount. Now on addition of small amount of HCl to this solution, now HCl will provide H plus ion in the solution. This H plus ion will combine with the acetate ion present in the buffer solution and form undissociated acetic acid. And so the addition of H plus ion from HCl will not change the pH because the pH is reserved by the acetate ion. Now small amount of sodium hydroxide when we add, now this small amount of sodium hydroxide will provide OH minus ion. Now this OH minus ion will make the acetic acid more ionizable, and acetic acid will ionize more and gives H plus ion, and this H plus ion combined with OH minus ion to produce undissociated H2O molecule. So the addition of OH minus ion, the pH is change of pH is resisted by the undissociated acetic acid molecule, which on addition of base, its dissociation increases and it produces H plus ion, and that H plus ion combined with the OH minus ion and that produce undissociated H2O and resist the change of pH. They resist the any change of pH. So this is the case of acidic buffer. Now for basic buffer action, now we take the example of equimolar solution of ammonium hydroxide and ammonium chloride. Now in this mixture, ammonium chloride is completely dissociated and form NH4 plus ion and Cl minus ion, and so the solution contain large number of ammonium ion and chloride ion, and also large number of undissociated ammonium hydroxide, because ammonium hydroxide weak base, it dissociate very less extent. Now when small amount of HCl is added, the dissociation of ammonium hydroxide increases and it produces ammonium NH4 plus ion and OH minus ion. Now NH4 plus ion combined with OH minus ion to form undissociated water. So the addition of excess H plus ion is neutralized by the dissociation of NH4OH that is sodium hydroxide, and that sodium hydroxide provide OH minus ion, and that OH minus ion combine with H plus ion to produce undissociated H2O, and thus it reserves the pH of the solution. When small amount of sodium hydroxide is added, now the excess amount of OH minus ion is combined with the available NH4 plus ion in the solution and produce undissociated NH4OH, and so addition of OH also not change the OH minus ion, also not change the pH. pH is reserved here by the